I execute the statement c equal to a plus b, where a and b are two integers, what compiler will do? It's a too silly question, isn't it? Yes, it is. Because when we apply an operator with the known types as the operands, compiler already knows what to do. For example, if we add integer plus integer, compiler knows what to do. If we also add integer plus a fractional number, let's say float, compiler knows how to convert that integer into a float and do the floating point arithmetic. So all these things are known to compiler. So all the arithmetic operators, relational operators, and many operators actually works when we use them with known types as operands. Now let's say we implement a class to represent a matrix, and if we say m1, m2, m3 are matrix instances or objects, then can we write m3 equal to m1 plus m2? Not yet, because compiler doesn't know what to do when the operands are class instances. So therefore, as a normal solution, we can write a regular method like add method to the matrix class, and we could call it from the main or from whatever the caller function, like m1 dot add, where m2 could be parameter, or m2 dot add, where m1 could be parameter, and that add method actually can return the resultant matrix. But isn't it more intuitive if we could use the plus operator with m1 and m2? So if we could write m3 equal to m1 plus m2, that could be much more intuitive and convenient for programmer. How can we do that? Nothing complicated. All we have to do is tell the compiler that I am giving you a additional definition of plus operation when the operands are matrix instance, matrix class instance. How do you do that? By introducing a special purpose method called operator method or operator function. So how does compiler detect that operator function? The function name itself, the member function name itself, begins with the keyword operator along with the operator, suppose in our case operator plus. So the quote-unquote operator plus is the method name, okay? And in the definition, we actually explain what to do to produce the effect of addition of two matrices, and that is all about. So without further delay, let me explain using C++. So I have already created a code blocks project with pre-written code to save the length of the video. Okay, in this project, if you look here, I have created a class called matrix, and since we don't know the number of rows and number of columns, so it's a better choice to use a double star pointer and allocate the necessary memory depending on the number of rows and columns of that particular instance. So we have two variables, rows and columns, and we use a double star pointer to store the matrix values. Okay, so we have a default constructor. We set the rows and columns to 0 and the pointer to null. Okay, there are some getter methods and setter methods. Now I can discuss them afterwards, not at this point. Now to start with, we have a method called setMatrix, which will actually populate a matrix instance. So it's asking how many rows and columns, and then accordingly it's allocating memory to the double star pointer val ptr. Okay, so first it's allocating single star pointer for the number of rows, and to each of those single star pointers it is allocating memory for the column. So once the memory is allocated, now it is asking for the elements for each of the rows, and eventually the matrix is populated. Okay, so that's the method setMatrix. Cool, nothing complicated. Now if we want to display the matrix in a row column fashion, then again we have written another method called showMatrix. Now we are checking if the pointer is null, that means there is no data. Otherwise we are running the loops and we are printing the elements within the row with space, and after row we are switching the line. Okay, so we see the matrix in a row column fashion. Okay. Uh, if there is no data, it will show an error message. Okay. So that's all about the matrix setup and matrix display methods. Okay. Now, if we want to add two matrices, as I said, we could introduce a add method. Now again, these are all member functions or methods. So to call these methods, we have to, that means the caller function, in our case main, the caller function have to specify uh, an object instance as client. Okay. Okay. So therefore, the class instance or object should be given as client. So let's say we have the main function. So we have some matrices m1, m2, uh, several objects we have declared. Default constructor got fired, so initially everything is null. Now we are asking, we are prompting user to input for the first matrix. So basically we are calling the method. The main function is calling the set matrix method, making m1 as the client, and also it is calling the set matrix method again, but for this time specifying m2 as the client. So the set matrix method will actually set the matrix, okay, according to the code that we have written. Okay, so it will populate two matrices m1 and m2. Okay. By the way, if you are not familiar, if you're very new to the programming language learning phase, and if you're new to class concept, so there is a video in this channel regarding class versus structure. So you can actually check it out here, the card for that video. Okay. Now we want to add two matrices. So what we can do, we write another method add. Now if you see here in the main function, now let's say we don't overload the operator yet, so we can actually write the add method. So now we have populated m1 and m2, so data is there. So now we can say m1 is the client, because we need to use an object to call the method. So all the fields of the m1 will be available to add method, and also it needs to use the field values of another matrix m2, so we send m2 as parameter. Now this add method use the fields of m1, which is the client, and the m2, which is the parameter, and add their corresponding valptr ij, because valptr is the pointer which holds the data in allocated memory, and it produce a resultant matrix which is assigned to m3. So the add method should returns a matrix object. Okay, so therefore the add method, if you see here, return type is matrix. Okay, now it is returned by value because we are declaring a temporary object called temp local to the method. Okay, so now we are checking the credential whether the addition is allowed or not. So we are checking the rows, number of rows of the client, in our case m1, with the number of rows of parameter m, which is the actual parameter is m2. So similarly we are checking the column values and rows values of both the matrices. If they are equal, then we are actually know that the added matrix also will have the same dimension. So we are also setting up the rows and column values of the temporary object temp, local object, and now we are allocating memory to the local object. Also memory requirement also will be the same, because if matrix m1 and m2 has 3 rows and 3 columns, matrix temp also will have 3 rows and 3 columns. So we are allocating memory there too, and then we are adding the actual elements, which is valptr ij of the client object m1. So we don't need to specify anything. But the non-client object, which is m2, which comes as parameter m, now we are telling m dot valptr ij. So the elements are added, and we store it into the valptr ij of temp. Okay, so we are adding valptr ij of client object with the valptr ij of the parameter object, and storing as a resultant value into the same location of valptr of the temporary object temp. So eventually we are returning temp. If the addition is not possible, we are sending some error message, okay? And since we have to return temp, we are actually setting the temp with null because addition was not possible. So, but we have to return temp because return type is matrix. So we are returning an object without any memory and the rows column set 0. Actually, this return statement is not necessary here because anyway, after if else we are returning temp, so that is suffice. Okay. So if we run this now, if I look at the main, so we have called m3 equal to m1 dot add m2. So addition is achieved. And if I want to show you the effect, now I'm printing m1, m2 and m3, all three matrices, and we can check that our program is working correctly. So addition is achieved. Okay, so let me comment from this point onwards to show you the effect of what I have discussed so far. Okay. Okay. So I will unveil the remaining course gradually since as we progress in our discussion. Okay. So right now in our main, we are taking inputs for m1 and m2, and we are adding m1 with m2 by calling a regular method add of matrix class, and we are printing m1, m2 and m3 to see the effect whether it's working or not. Okay, so that is the main function so far. Okay, so return 0. Okay, so if I try to build and execute, okay, compiled. So it is asking, now this is the effect of m1 dot set matrix. Okay, so it is asking for number of rows, let's say 2 to keep things simple, 2 by 2. Okay, now let's say the row 0, 1 and 2, and row 1, 3 and 4. So that is done. We are done with m1 dot set matrix. Now m2 dot set matrix will be called. Again it is asking, let's say again 2 by 2, and let's say 5 and 6 and 7 and 8. If the dimensions are given differently, matrix addition would not be possible, so it would show the error message. But anyway, we want to see that addition is happening, so intentionally I have given the same dimension. Okay, now we called m3 equal to m1 dot add m2 as parameter, so m3 should have the added matrix, and the add method returns the matrix which was temp in our case. So now this is the m1 dot show matrix, m2 dot show matrix, and m3 dot show matrix, and now you can see that the m1 and m2 are added, okay, and stored in m3. But you see, we call the add method, but wouldn't it be more intuitive and natural looking if we could use the plus operator like this? So right now this will not work because compiler doesn't know what to do if the operands are matrix objects with plus operator. So if I try to build, it will give me error. Okay, right now it is not giving error because the code is already implemented for operator function. So if I comment that operator function, okay, so now we have add method, but we did not overload the plus operator so far, so it will give me error. Okay, so it is telling the operator plus, okay, no match for operator plus. So it is looking for the operator function. Now as I said, the operator function name begins with the keyword operator. Okay, if you see here, begins with keyword operator with the operator that we want to overload, in our case plus. So it is looking for that. Okay, so that is the operator function. So to make this work, we actually have to overload the plus operator. Okay, so what we can do, we can write a, now you see it is a binary operator, So one of them will be the client in the call, and another one will be the parameter. Now if I say m1 plus m2, now actually compiler will not toss the coin and make the decision which one to make the client. Sometimes m1, sometimes m2. No, it doesn't work. So to keep things consistent, the rule is made that always the first operand, so that is the left hand side operand in case of binary operator, because binary operator has two operands, the first operand will be the client. So if I want to explain to you how this call will look like, let me try to explain. So if I write like this, now interpretation of this will be m1 will be the client, so dot, and the method name is operator plus, because we are trying to overload the operator, and the m2 will be the parameter. Okay, and the method, the member function, the name of the member function or method is operator plus. Now this method should return a matrix so that we could assign it to m3. Okay, so therefore we have to write a operator plus function, that is the operator function, member function, to the matrix class to make this work. Okay, and that operator method or member function should return a matrix which will actually add m1 with m2. Okay, so if we implement that method, then automatically this will work. So whenever we use the operator with the objects, it actually looks for the operator method, and as a rule the first one will be the client like this, and the second one will be treated as the parameter of that method. Okay, however we cannot write this because this is not the syntax, this is the syntax, but I just showed you this will be the interpretation. Okay, how the function will look like, okay, internally. Okay, so therefore we have implemented now a operator function. Okay, so now you see add method is there. Okay, so add method will help if we call if we want to perform the addition by calling that method like this. But if we want to use the operator with our objects, then the operator plus version will be executed. So similar, but the name of the method is operator plus. So m1 is the client, m2 is the parameter. Now again similar code to the add method. So it is actually doing the addition and it is returning the temporary object temp, which goes to m3. Okay, so now if I write m3 equal to m1 plus m2, now it will find the operator function available, okay, which is this as part of the matrix class. Okay, so this is the end of matrix class and this will work. Okay, so simple, not much complicated. So let's try to run it. Now I have used the plus operator. So again, let's say 2 by 2, 1, 2, 3, 4. Now again 2 by 2, 5, 6, 7, 8. Still it is working. Okay, so very nice. Okay, so we are satisfied. As a programmer, I am satisfied because I could use the operator with my objects. Okay, so m3 equal to m1 plus m2 and it's working. Okay, so that is the basic of operator overloading. So when we want to overload an operator, then we have to actually add a operator function. Okay, can we overload all operators? We can overload most of the operators. We actually cannot overload few operators, 7 or 8 of them, like size of, scope resolution operators. Okay, a dot operator to represent the member. Okay, etc. So the Bjorn Strastrup, who is the designer of the C++ programming language. Okay, so I provide a link below and you can actually read his own opinion why those operators cannot be or need not to be overloaded, and that's why it was not provided. Okay, so I'm not getting into that discussion, so let's continue. Okay, now if you see here, now let me continue progress with the main function pre-written. Now if you see, uh, now if I want to add a specific value to a matrix, what does that mean? We don't know. Now it depends on the interpretation. Now suppose we want to increase the value of matrix M3, each of each of the elements of matrix M3 by 2, then the operator method will not work that we have just written, because the parameter of that operator method is another matrix. So that will work for M1 plus M2, object plus object. So the first one is the client, second one is the parameter. So it will work for that, okay, like this. The object is the client and the second object is the parameter. But in this case, it is object plus integer. Now we know the first operand will be the client, so M3 is an object, so it qualifies to be a client, no problem. But the 2 should go as parameter. So we can actually overload the operator and provide multiple definition, okay? So that is called function overloading or method overloading. You can have multiple definition of the same function or method, in our case operator plus, if we will, and that is called function or method overloading. So if you are new to the concept of method or function overloading, also there is a video on that, so look at the card somewhere there. Okay, okay, so now we want to have multiple definitions, so we can have another definition of operator plus where the parameter is integer. Okay, now we could write the definition here itself, but to keep the class smaller, we are writing the prototype only here and provide the definition below. You can do that. Okay, so it means there is another method operator plus whose parameter is integer and which returns a matrix. So we provide the definition afterwards. This one. Okay, so operator plus parameter is now integer instead of matrix and return type matrix. Now this matrix colon colon, that means it's a scope resolution operator. It tells that this operator plus we are defining outside main function, sorry, outside the class definition. So if we don't provide this, then now compiler will treat that as a global function, but it is not. It is a method or member function of the matrix class, and we have provided the prototype there. So therefore we have to tell now this matrix colon colon represent that this method is part of the class matrix and this class matrix, and this matrix is the return type. Okay, so similar to that, just we have defined the function outside of the class. Okay, so we are specifying it's not global, it's a method of that class. Okay, but otherwise it is same. Okay, so return type matrix and the parameter is integer. So for this matrix plus integer, M3 will be the client, 2 as integer will be the parameter, and that's what is happening here. Now again temp, but now we are actually after allocating memory to temp, what we are doing, we are adding x, which is the parameter, with each value of the valptr of the client object and assigning the sum as the element of the valptr of temporary object. We are returning temp. So therefore when we call M3 plus 2, basically 2 is added with each elements of valptr of M3, which is stored in temp, and temp is assigned to M4. So M3 plus 2 actually will work. Okay, so let's see whether it works or not. So now we want to see up to this and execute it once again. Okay, so 2 by 2, this is M1, let's say 1 2 3, 4. Now again 2 by 2, that is for M2. So let's say 5, 6, 7, 8. Oh, I have given 3 columns. Okay, so it will not be possible to add. So let me run it again. It will show error message. Okay, so 2 by 2, 1, 2, 3, 4. Now again for M2, 2 by 2, 5, 6, and 7 and 8. Okay, now M1, M2, M3 equal to M1 plus M2, so therefore M1 plus M2 we are getting M3, no problem. Now we said M3 plus 2, M4 equal to M3 plus 2. So now the integer parameter version was executed where M3 was client. So 2 was added with each element of M3 and temp was written and assigned to M4. So this is M4. Okay, now see 2 is added with each element. Okay, so it's fine, working fine. So you can actually overload the operator function too, okay, and have as many versions to make the variation of the parameter. Okay, now the next one we want to have is 5 plus M4. That means integer plus object. Now that has little problem, and the problem is, let me explain. The problem is, we know that first operand will be the client. Okay, now 5 is an integer which does not qualify as an object of matrix class, so the 5 cannot be used as a client to call the operator function. Okay, so that is the problem. And also M4 cannot be the client because it is not the first operand. Okay, so therefore how can we do that? So we cannot actually make it as a method version. Okay, we cannot actually overload this operator as a method version of the class. Okay, so we cannot implement that operator function as a member function of the matrix class. Okay, because the first operand is not a matrix class object, it's an integer. Therefore now we have to implement it as a global version. Okay, so let me see the global version. Okay, so this is the global version. Okay, so now since okay, now before getting into the definition, if you look here, now M1 plus M2 was the member function or method version. So M1 was the client, it was automatically available to the method, and M2 became the parameter. So one was client, so the other one was parameter. Okay, same thing here. The object was client, first operand, so the second operand, integer, was the parameter. But now in this case there is no client, therefore both of them should be parameter, and since there is no client, it has to be a global function. Okay, so we implement a global version of the operator plus. Now it is a global function, it's not part of the class, and both the integer, because we have written integer plus object, so both integer and the object are parameters. Okay, but the problem is, as a global function, it does not have direct access to the private fields of the matrix class. Okay, which are rows, columns, and val ptr. Okay, so that's another new problem. For methods or member functions, it was not an issue. Whether the fields are private or not, it doesn't matter, they can always access them. Okay, but now suddenly this global version don't have any access to the private fields of class matrix. Okay, so therefore we have to use some getter functions, getter method, to get the value of the field, private field, or we could also use some setter method to set the value of a private field, because we cannot directly read a private field value from a outside non-member function, in our case a global function. Neither we can write into the private field directly. Okay, so we are actually calling the methods of the matrix class to do that on behalf of this global function. Okay, So this global function want to assign some value to the row of temp, but it cannot do that, so it is calling a method of matrix class actually to set the rows value on behalf of this global function. Okay, so that is why we have written some setter methods and getter methods at the top of the class. So you can see that set rows, where the parameter is given and the rows value is set. Okay, same thing for set columns. Okay, for val ptr, the number of rows and number of columns are given as parameter. So accordingly, once the rows and columns values are set, it can allocate memory, okay, and assign the values. Okay, so that is all about setter methods. Okay, now setter methods. Okay, now the getter methods will return the field values. So val ptr will return the reference of the val ptr. Now we don't want a copy pointer, we want the reference of the same pointer, which is a field, so return type is reference. Okay, and the type of val ptr is in double star, so return type is in double star and reference of that. Okay, because we don't want to return the copy of the field, we want a reference of the actual field, which is val ptr. Get rows, return the value of the rows. Now we need the number, the value of the rows, so copy is fine, return by value. And get columns, also return the column. So these are all getter methods for those individual fields, and these are the setter methods for those individual fields. Okay, so as the global function, because to accommodate 5 plus m4, where suppose we want to increase the value of m4, each value of val ptr ij inside m4 by 5, but now it's a global version and both of them are parameter. Now to read and write, because it has to read the field value from m4, and after adding 5 it has to store that into the field value of temp. So it has to use the getters and setters because it cannot directly access the private fields. Okay, so therefore what it is doing, it is actually checking whether the rows and columns are 0 or not, because that means the matrix is not not populated of m. If it is not non-zero, then there are some elements. So now it is setting the value of temp, because temp is the temporary matrix, by calling the set rows. Now what will be the row value of temp? The row value of the matrix m. So m dot get rows will give back the row value of m, and we are using that as parameter to set the row value of temp. So we are setting the row and column of temp, and now we are allocating memory to val ptr of temp. So done. We cannot do it directly here like previous two versions, because they were method versions. So we had to use the getters and setters. Now once we are done, we run the loop again. We are getting the row value and column value, and then we are actually getting individual values from the val ptr from the position ith row and jth column, and adding it with x, and use that added value. So get val ptr value at will return you the val ptr ij from m, add x with that, and use that value to set val ptr value at I comma j of temp. Okay, so hopefully you understand. So let's see the set val ptr value at and get val ptr value at. Okay, so get val ptr value at is basically returning you the value of the parameters. Okay, that is the row position and column position. Set val ptr value at this particular index, row position and column position, with the value val. So val ptr, this row position and column position equal to val. Simple, because that's a global function, so it cannot directly set the value, so it is using these methods to read the value from a particular position using the get valpitier value at and adding 5 with that and storing it into the position of temp. Okay, that's why we are actually using these two. Okay, so if you just have a look, you will understand. Okay, okay, and then we are returning temp, so we can return here one return is enough. Okay, so that is basically the global version. Now the problems that comes with as baggage with that global version is that we have to write multiple getters and setters. Okay, because we cannot access means the global function cannot access the private fields directly. Okay, so that's the problem, but we have to live with it. That's the rule of the game, because any outsider global function or method of some other class cannot access private fields of a particular class. Okay, so is there any easier alternative? Yes, it is. Now let's see first whether it works or not. Okay, so in our main, now we want to see 5 plus m4. Okay, so let's see. Okay, so first matrix 2 by 2, 1 2 3 4. Oh, again I have given number of columns 3, so it will be bigger, so make it small. Okay, so 2 by 2, 1 2 3 4. Now for second matrix, let's say again 2 by 2, 5 6 7 8. So these are m1 m2, so this is m1 plus m2, which is m3. Now m3 plus 2 is added. Now 5 plus m4, now this is m4, now 5 is added with each of them. Okay, so the global version is working perfectly. Okay, so now for this it is 5 plus m4, which is integer plus object, so 5 is not the client, so the global version is called, and this particular operator plus global version used getters and setters. Okay, to do the operation, matrix addition. Okay, cool. Now do we have any easier alternative instead of using lot of getters and setters? Yes, we can. Now let's see what we can do for that. Now this is the getter setter version for operator plus that we have used. Okay, several getters and setters to do that. Okay, now let's comment this and pretend that it's a global function. In that case, it was not necessary to use getter and setter, but of course it is not a global member function, it's a global function. But for time being, if you pretend that it's a global function, then you can directly write m dot rows. Okay, temp dot rows equal to m dot rows. Okay, temp dot valpitier equal to, okay, like that. Okay, temp dot valpitier ij equal to m dot valpitier. Very simple. Okay, so therefore if this particular global function could have access to the private fields of matrix class, this could work. Okay, and we could actually get rid of using so many getters and setters. Okay, so is there any way to allow access to a non-member function to the private field? Yes, it is. So if a class thinks that sometimes I need to give access to some non-member function to my private data, then the class can declare that non-member, either it's a global function or method of some other class, non-member, as friend. Okay, so now it's a global function, so the class need to declare this particular function. Even though my fields are private, it will remain private to any other outsider except this particular global function, because I want to treat that particular global function as my friend. That's it. So if the class declared this outsider non-member as a friend, then suddenly that global function can have access to the private fields and our code become much simpler. So how to declare a friend? Now go back to the class definition. Now this is the class definition. Okay, now it tells, okay, there is, now we have to use the prototype of the function outsider whom the class wants to declare as friend. So that is the prototype. Okay, there is a global function operator class, has two parameters. First one is integer, second one is matrix, and the return type is also matrix. Okay, and I declare that outsider as my friend. I'm in the class, and suddenly that global function have access to all private fields, okay, of the matrix class. Very elegant. Okay, but still the private fields are protected, not accessible to any other global functions which are not friend. Okay, so it still holds the property of protection, data protection to other outside functions which are not member function or method of that class. Okay, so let's test that. So now I have commented that getter setter version. Now again I'm going to run the same program, but now it will execute the friend version, but since it is declared as friend, this global function can access to the private fields of the matrix class. Okay, so let's run it. Okay, this is redundant actually, not necessary. Okay, so 2 by 2, 1 2 3 4, again 2 by 2, 5 6 7 and 8. Okay, now you see that is M4. Now 5 plus M4. Now the friend version is executed. Now even though being a global function, now it can access the private fields directly. Okay, so you can actually declare a global function or a method of some other class as friend and grant access to your private field if you are a class. Okay, okay, so far so good. Now let's look into the main. Okay, now if we want to use the unary operator, if we want to overload the unary operator, then what will happen? Now we have seen all the examples so far for the plus operator, which is a binary operator, so it has two operands. So therefore the left hand side operand became the client, the second operand became the parameter if it is a method version. If it is not possible to have a client, in case the left hand side first operand is a non-object of that class, then we can have global version, but then both operand will be the parameter. Okay, now for unary operator you have only one operand involved, like I plus plus, the only operand is I. Okay, or I minus minus. Okay, so then that particular object will be the only operand, so that will be the client. So therefore nothing to pass as parameter. Okay, because like M1 plus M2, M1 was the client, so M2 was the parameter. M3 plus 2, M3 was client, 2 was parameter for method versions. Okay, and for this global version both of them is parameter. Now if you see plus plus M5, now M5 is the client and no other operand is involved here, therefore there will be no parameter. Okay, so now let me show up to this. Where is that? Okay, okay, so now we want to overload a unary operator, for example plus plus. Okay, and now in this case it is pre-increment, so plus plus M5. Okay, now pre-increment and post-increment has a minor difference when they are used in expression. Okay, now for example if I say if I is 10, okay, and j is also 10, Now if I say I plus plus, that is post increment, or plus plus j, that is pre increment, in both case I will be incremented to 11, okay, and also j will be incremented to 11. So when they are actually used as a standalone statement, their effect is same. However, if they are used in an expression, then actually they differs, okay. So for example, if I say m equal to I plus plus and n equal to plus plus j, now I and j will be incremented to 11, no doubt about that, because plus plus is used there, okay. But which value of I will be used in the expression while assigning to m or n, that actually decided by whether it is post increment or pre increment. Post increment means use the current value and then increase it. So therefore, before increase, the value of I is 10, so m will be 10, not 11. But here it is pre increment, it means increase the value first and then use in the expression. So therefore the n will be 11 too, okay. So that is the difference between post increment and pre increment, okay. Now in this case it is pre increment, so the value of m5 matrix will be incremented first and that will be assigned to m6. So there will be no parameter, and because m1 is the client, so the member function or method name will be operator plus plus, okay. So if we go to the class, you see operator plus plus and no parameter, okay. And since we are telling that m6 equal to plus plus m5, so this operator plus plus should return a matrix. So return type is matrix or matrix reference, okay, reference of a matrix. Reference of a matrix means it will return the reference of the client, in our case, which is m5, not a copy of m5, okay. So if you don't give reference as return type, then it will return a copy of m5, okay. Now we are going to increase the m5 anyway, so instead of returning a copy of m5, we could return the same m5 itself, okay. But in both case you will have the value in m6, okay. So let's see the we have defined the definition outside class, so we have given the prototype, okay, and we have implemented afterwards. We could also implement it here itself within the curly braces, but to keep the class size smaller, we have implemented outside, okay. So if we implement a method member function outside, then we have to tell it belongs to the class, okay. So we are telling that operator plus plus, which is a method of matrix class, okay, takes no parameter and returns reference of matrix. Now anyway, what we are doing, we are increasing the elements of the client. Now we could use plus plus valptr also instead of valptr plus plus, doesn't matter because it is used as a standalone statement. It has no effect, as I shown you here, that when you use them as a standalone statement like I plus plus or plus plus j, anyway they will be increased to 11, okay. So effect same, okay. So therefore we are increasing the values, the matrix elements of the client, okay, and we are returning the client itself. Now you know that this pointer is a special pointer which points to the client at a given point of time. So in serial execution, unless your program is parallel computing, you are implementing a parallel program using multi-core, okay, this pointer will point to one object as the client, okay. So when you call a function or a member function or method like m1 dot show matrix, now as long as the show matrix will be executed, m1 was the client, so during that time this pointer will be pointing to m1. Now after some times again, if you call m2 dot show matrix, now show matrix method is called again, at time period t2. Now during time period t2, this pointer will be pointing to matrix object m2. Okay, so this pointer will always give you the address of the client object. Now we dereference the pointer, we get the object, and we return the object as the reference, not as a copy. So we return the client itself. Okay, so after increasing, so therefore m5 will be incremented first according to our main, and we return the m5 itself, not copy of m5, to m6. So if we print after that the m5 and m6, m5 dot show matrix, m6 dot show matrix, we will see that m5 was incremented first, and that incremented matrix was returned and assigned to m6. Okay, so let's try to execute that. Okay, so 2 by 2, 1 2 3 4. Now again 2 by 2, 5 6 7 and 8. Now if you see, that was m5. Okay, now that is m5. Okay, now we called m6 equal to plus plus m5, so m5 is incremented by 1, pre-increment, so it will increase the elements of m5 first, and then m5 will be assigned to m6, so pre-increment. So it is incremented, and that pre-incremented value is assigned to m6. Okay, so m6 is having the same value after m5 was incremented. Okay, that is why it is pre-incremented. Okay, fine, cool. Now if we want to use post increment, then what will happen? Okay, so like this. So now I'm telling m6 plus plus, and that means the current value of m6, whatever the elements of m6 before increment, should be the elements of m7, and then m6 should be incremented post increment. So how do we do that? Now again m6 is the client, because that is the only operand of the plus plus and no parameter. Okay, so we could add another operator plus here. So we have one operator plus plus. Now we could have another operator plus plus, where we could write the postfix logic inside. But the problem is we cannot have two definitions. Now suppose we want to, this is the prefix version. Okay, so we could have another definition for postfix version. Okay, so let's say we can have another definition of the postfix version. Now postfix version, but the problem is, for we cannot actually have two definition of a method or function with same parameter list, same signature. Okay, now in this case the prefix version and postfix version has the same parameter list. Okay, 0 parameter, because m5 plus plus has no parameter, m5 is the client, plus plus m6, again m6 is the client, because that is the only operand in the prefix or postfix. In both cases the object is the only operand, so therefore it is the client, so therefore no parameter. But that's the violation of the method overloading or function overloading. You cannot overload, you cannot provide multiple definition with the same parameter list. So if you are unfamiliar with the concept method or function overloading, please look at a video in the playlist below on function or method overloading. Okay, so therefore compiler knows this is a unique context, okay, for plus plus and minus minus, because they have pre and post version. But in both cases there is only one object, and that will be the client. So in both cases there will be no parameter. Then, but to make both of them work, we need to have two different definitions, because one should be use the old value and then the values should be incremented, and another should be incremented first and then use the latest value for pre-increment. For post increment use the old value and then increment. So their code will be a little bit different, So we need two different definitions, but the problem is we cannot have two definitions with same parameter list like this. So prefix version and the postfix version, we cannot actually have them. So compiler designer knows that problem, so they came up with a unique solution. Okay, they said, okay, so to make the method overloading work, we will allow one version a parameter. Now let's say the postfix version, we allow an integer parameter, let's say x. Now the method overloading is allowed, but the beauty is while calling, you don't need to supply any integer as parameter. So you call simply like this. Okay, what is that? Okay, so if you call the prefix version, then the 0 parameter definition will be executed. If you call it as a postfix operation, then the parameterized version will be executed. So the problem solved. But now you see, we said the parameter is integer, but we have not provided an integer here like this. Okay, so therefore it's a special, but it will be taken care of by the compiler. It will work. Okay, so it is decided that non-parameterized version is for prefix version for plus plus or minus minus, and the parameterized version is for postfix for plus plus and minus minus. So in postfix version we have to provide a parameter to actually provide multiple definition. Okay, so I already have it, so that is the parameterized version. Okay, so this is the non-parameterized version for prefix to work, and that is the parameterized version for post increment to work. Okay, so that is for pre increment. Okay, that is plus plus m5, and that is for post increment, that is m5 or m6 plus plus. Okay, so what we need to do, how the internal mechanism differs here, you could increase the elements of the client and return the client because it is already incremented. So pre increment is fine, but now we are going for post increment, so we have to store the current value because we have to increase the elements of the matrix anyway, whether it is pre increment or post increment, whether the plus plus is a prefix or postfix. In either case you have to increase the elements of the matrix, but we have to use the old value of the elements while returning. So we are storing the old value into a temporary object temp. Okay, so we are doing that. Okay, so we are telling temp dot valptr ij equal to valptr ij post increment postfix. Okay, so what happens, it assigns the current value of the client to the as the value of the temp, and then it increases the current value. So we cannot actually return the client because client's values are already incremented, but we can return the temp because temp is used to store the previous value of the valptr. So we return temp. Okay, so therefore now when we call the postfix version, it automatically detects the integer parameter version, parameterized version, and it returns temp. Okay, so therefore now we'll see that m6 will be increased, the elements of m6 will be increased by 1, but the elements of m7 will have the old value of m6 because it is the plus plus was used as postfix, that is post increment. Okay, not pre increment. So let's run it. Okay, so 2 by 2, sorry, 2 1 2 3 4. Now again 2 by 2 5 6 7 8. Something went wrong, let's see. Oh, yeah, I just need to remove that, it's redundant. Okay, okay, 2 by 2 1 2 3 4, again 2 by 2 5 6 7 8. Now see, that for M6 it was plus plus M5. Okay, so M5 was incremented and that incremented M5 was given to M6. But now this is M6, now M7 is M6 plus plus, so M6 is incremented from 14, 16, 18, 22, 15, 17, 19, 21, but M7 still have the old value of M6 here because of the post increment. Okay, so that is roughly about the operator overloading. Now so far I have shown you the arithmetic operators, plus and the plus plus, okay, for addition, but you can also use many different types of operators, okay, except a bunch of them. The link is given below to look into the view of the designer of C++, why he did not provide the overloading facilities for those operators. Okay, now let me show you another example of a different type of operator other than arithmetic operator. Now let's say subscript operator. Okay, so I have created another class in a different file. Okay, so let's say the class name is array. Okay, so we actually want to represent an array as a class, so we created a class. Now the array has a size, and if the elements are integer, we have a pointer. Okay, so set array will ask for the size, allocate memory to pointer, and it will ask the elements for the array from user. Very simple. Okay, so that is set array. Similarly, if we want to show that array object, so we call the show array method. So what it does, it shows the elements, okay, from the allocated memory ptr using the loop ptr I. Okay, now we want to overload the subscript operator. Okay, now you see, when you declare an array in real array, you can use that subscript. Okay, now for example, if you declare a real array, for example, int arr of size 10. Okay, now you can actually choose to view the fourth element, and you can say cout arr of 3. Okay, that will give you the fourth element. But in our case, if there is an object, okay, now if you say your array is a class, okay, array, now let's say arr object, now it's an object. Now inside the arr object there is a ptr, so basically an element of that object will be arr object dot ptr of index. Now if your index is 3, you want to see the fourth element of ptr, which is a field of your object, a class, where arr object is a client. So you see, that is the problem. It's not a normal array. Okay, so you have a pointer that can be treated as an array, but that's a field of your class. So actually, to get the element, it will look like this. But you want to, instead of this, you want to use arr object of index. Now you know that arr object is not an array, it's a object of array class, but you want to treat that as an array, the object as an array, so you have to overload the subscript operator. Okay, you can do that. That's what we did here. Okay, so what I did, I overloaded the subscript operator, so therefore the method name is operators subscript. Okay, and then the parameter is an integer. Now we are returning the elements in that position from the pointer ptr, okay, which can be treated as an array after allocation of memory. So now you can actually use this with your object and give an illusion that your object is an array. Okay, So that is the beauty. Now I have not written a main in this class, rather I have imported this class, this file, which is subscript operator.cpp. So I have actually imported that in my previous program. So I have imported hash include subscript operator.cpp that automatically makes that array class into this program. Okay, now the within inverted comma means the file is not in the standard library folder, it's in the current folder. Okay, so now I can actually use that. Okay, so let me comment this main which I used to explain the matrix operations. Okay, and let me use another main. Okay, this one. So what we are doing here, we are actually declaring an array class object arr. Now arr dot set array will populate the array. Okay, it will ask the size of the array, allocate memory to ptr inside arr, and ask for the elements, and arr show array also will show the array. Okay, now we are asking to view an array element, enter an index. Okay, now user is telling I want to view this particular element, so user is giving the position of the element within the array, which is part of the array class. So now we are checking whether it's a valid index or not. So there is a member function method is valid index. So we are calling that method with the object arr as client and sending that user input. Now it checks whether it is between 0 and size minus 1 or not, and also the size should be greater than 0, then it's a valid index. Then we are calling the operator function by treating our object as an array. So we are actually saying that arr of index here. Now you see arr is not the array, arr is the object, but we overloaded that subscript operator so that this will actually call the operator function with the operator subscript, and it will pass the index and it will return you the element. Okay, and it will work. Okay, so let's run it. Now we have changed the main. So now it is asking enter the size of the array, let's say 5. Okay, so these are the part of the set array method. So let's say, so these are the elements, so that ends the set array. Now the show array will show you the array, show array method. Now it is asking for an index, let's say 3. So 3 means 4th element, so it should print 44. Okay, so it's working fine. Now this is working because we have overloaded the subscript operator, otherwise it would not have worked, because your arr is not an array, arr is the object. Okay, so that is all about operator overloading. If you have enjoyed the video, please give us a thumbs up and share it with your friends, and don't forget to press the notification bell so that you don't miss any future videos. Thanks for watching. Have a good day.